Pavement and foundation engineering. Pavement can be defined in different ways. A pavement is a smooth and hard surface built to carry the traffic load under all climatic conditions. A pavement structure is needed for two reasons. Number one, the natural earth surface cannot support the modern heavy wheel loads. Number two, the natural earth surface cannot provide an adequate smooth wearing surface. Therefore, a constructed pavement distributes the wheel loads efficiently and provides a necessary smooth wearing surface. Functions of the pavements: reduce and distribute the traffic loading so as not to damage the subgrade. Provide vehicle access between 2 points under all weather conditions. Provide safe, smooth and comfortable ride to road users without undue delays and excessive wear and tear. Meet environmental and aesthetic requirements. Limited noise and air pollution. Reasonable economy. That means we are having an impact, a positive impact on the economy of the state. Requirements of pavement structure: sufficient thickness to spread loading to a pressure intensity tolerable by subgrade, sufficiently strong to carry imposed stress due to traffic load, sufficient thickness to prevent the effect of frost-susceptible subgrade. Pavement material should be impervious to penetration of surface water, which could weaken subgrade and subsequently pavement. Well, keep this thing in the mind that subgrade is, you can say, it's some sort of foundation for the pavement structure. Pavement material should be non-frost susceptible. Pavement surface should be skid resistant. Now look at the pavement engineering. Pavement engineering is a branch of civil engineering that uses engineering techniques to design, construct and maintain various types of pavements. This includes streets and highways and involves knowledge of soils, hydraulics and material properties. Pavement engineering involves new construction as well as maintenance and rehabilitation of existing pavements. Maintenance and rehabilitation often involve engineering judgment to make maintenance repairs with the highest long-term benefit and lowest cost. Methods of pavement design. There are in fact 4 groups: Group A, Group B, Group C and Group D. Group A. Under Group A we are having the empirical methods, and the empirical method using no soil strength test. Basic properties of soils are involved. And here we are having the methods like US Highway Engineers Group Index method and the Civil Aeronautic Administration USA method. Group B, empirical methods using soil strength. So here we are going to involve the soil strength parameters, and CBR, California Bearing Ratio test, is generally performed. So look at the different methods that we are having under this group. CBR method, North Dakota Cone method, US Navy and Flexible Pavement Committee method, Canadian Department of Transport method, Markwick method for rigid pavement, Overseas Road Note 31, and ASHTO Design Guide. Group C. Methods based partly on theory and partly on experience. Fundamental stress-strain properties of subgrade soils and sometimes the base material are determined by shear or bearing test. And under this group we are having the methods like Westergaard's method, which is based on the plate load test, shear strength method, Golders method, Kansas Highway Department method, and V.R. Smith method. Group D. Wholly theoretical method. These are based on mathematical analysis of the stresses and strains throughout the pavement and subgrade and the true stress strain characteristics of the various materials. So this is the most advanced, you can say, the method of designing of pavement. And here we are having the Burmster's analysis and design method under this group D. So types of pavements. Broadly speaking, we are having the two types of pavements, flexible pavement and the rigid pavement. So look at the flexible pavement first. Look at that. This is the subgrade, and upon the subgrade we are having the subbase. This is the subbase, and then the base course, and then we are having the asphalt concrete. This is the surface, you can say, of the pavement or the surfacing. So this is the typical cross section of the flexible pavement. Now look at the rigid pavement. In the rigid pavement we are having this cross section, typical cross section, the subgrade. Upon that we are having the subbase, the base, and at the top we are having the surface course, and this is made of cement concrete. In the case of flexible pavement we are having the asphalt concrete at the top, but in the case of rigid pavement we are having the Portland cement concrete at the top as the surfacing. So first look at the flexible pavement in detail. Three main layers: surfacing, and in the case of surfacing you can have the two layers. The topmost layer is called as the wearing course, and just beneath that we are having the asphaltic base course, which is also called as intermediate or binder course. And then we are having the layer of road base or base course, and then sub base. So look at this cross section. You can see this is the surfacing, the topmost layer, that is the wearing course, made of usually made of asphalt concrete, and then just beneath that we are having the base course, asphaltic base course, and then under that we are having the road base, or simply you can say the base course. Then we are having the sub base, and all this, in fact if you just look at this one, this is known as the pavement structure, this one, and it is supported by subgrade. So it is written over here that the pavement structure is supported by subgrade. So flexible pavements are so named because the total pavement structure deflects or flexes under loading. A flexible pavement structure is typically composed of several layers of different materials, as you have seen on the previous slide. Each layer receives the loads from the above layer, spreads them out, then passes on these loads to the next layer below. Thus, the further down in the pavement structure a particular layer is, the less load in terms of force per unit area it must carry. Structure of flexible pavement. In order to take maximum advantage of this property, material layers are usually arranged in order of descending load-bearing capacity, with the highest load-bearing capacity material and most expensive on the top, and the lowest load-bearing material and least expensive at the bottom. Surface course. This is the top layer and the layer that comes in contact with traffic directly. Then the base course. This is the layer directly below the surface course and generally consists of aggregates, either stabilized or unstabilized. Then subbase course. This is the layer or layers under the base layer. A subbase is not always needed. Subgrade. The subgrade is the material upon which the pavement structure is placed. Although there is a tendency to look at pavement performance in terms of pavement structure and mixed design alone, the subgrade can often be the overriding factor in pavement performance. So this point must be noted, that the subgrade can often be the overriding factor in pavement performance. Okay, now we are going to consider the various components of the flexible pavement one by one. First, look at the surface course. The surface course is the layer in contact with traffic loads and normally contains the highest quality materials. It provides characteristics such as friction, smoothness, noise control, rut and shoving resistance, and drainage. In addition, it serves to prevent the entrance of excessive quantities of surface water into the underlying base, subbase, and subgrade. This top structure layer of material is sometimes subdivided into two layers. Look at the wearing course. This is the layer in direct contact with traffic loads. It is meant to take the brunt of traffic wear and can be removed and replaced as it becomes worn. A properly designed and funded preservation program should be able to identify pavement surface distress while it is still confined to the wearing course. This way, the wearing course can be rehabilitated before distress propagates into the underlying intermediate or binder course. Intermediate or binder course. Intermediate or binder course, this there provides the bulk of the HMA, hot mixed asphalt. HMA stands for hot mixed asphalt structure. Its main purpose is to distribute load. Then comes the base course. The base course is immediately beneath the surface course. It provides additional load distribution and contributes to drainage and frost resistance. Base courses are usually constructed out of aggregates. Base courses are most typically constructed from durable aggregates that will not be damaged by moisture or frost action. aggregates can be either stabilized or unstabilized. HMA, hot mixed asphalt, in certain situations where high base stiffness is desired, base courses can be constructed using a variety of HMA mixes. In relation to surface course, HMA, hot mixed asphalt mixes, base course mixes usually contain larger maximum aggregate sizes, are more open graded, and are subject to more lenient specifications. Then comes the sub-base course. The sub-base course is between the base course and the subgrade. It functions primarily as structural support, but it can also minimize the intrusion of fines from the subgrade into the pavement structure, improves drainage, minimize cross-section damage, provides a working platform for construction. The subbase generally consists of relatively lower quality materials than the base course, but better than the subgrade soils. A subbase course is not always needed or used. For example, a pavement constructed over a high-quality stiff subgrade may not need the additional features offered by a subbase course, so it may be omitted from the design. However, a pavement constructed over a low-quality soil such as a swelling clay may require the additional load distribution characteristics that a sub-base course can offer. In this scenario, the sub-base course may also consist of high-quality fill used to replace poor-quality subgrade. And then the subgrade. Although a pavement's wearing course is most prominent, the success or failure of a pavement is often dependent upon the underlying subgrade, the material upon which the pavement structure is built. So that's why the subgrade is very, very important. Okay, now we will discuss the different components of the rigid pavements one by one. So you can see that this is the typical cross section for the rigid pavement. And in the rigid pavement, as you are having the cement concrete slab at the top, so you will have to provide the longitudinal joint and the transverse joints. So here you can see the basic components of concrete pavement. So you can see that we are having the panels, different panels of the concrete slab, and you can see the transverse joints, and you can also see the longitudinal joint. And at the joints, steels are to be provided. So you can see the dowel bars are provided at the transverse joint, and the tie bars are provided at the longitudinal joints. Rigid pavements are so named because the pavement structure deflects very little under loading due to the high modulus of elasticity of their surface course. A rigid pavement structure is typically composed of a PCC surface course built on top of either the subgrade directly or an underlying base course. Because of its relative rigidity, the pavement structure distributes load over a wider area with only one or at most two structure layers. There are other types of surfaces also, that is reinforced, continuously reinforced, etc. Now look at the structure of rigid pavements. At the top, surface course is there. This is the top layer, which consists of the PCC slab, reinforced or continuously reinforced slabs. Then under that we are having the base course. This is an optional layer. So here look at the word optional. I am using the word optional. This is an optional layer directly below the PCC layer and generally consists of aggregate or stabilized aggregate. Then comes sub-base course. This is the layer under the base layer. A sub-base is not always needed and therefore may often be omitted. So first look at the surface course. The surface course is the layer in contact with traffic loads and is made of PCC or RCC. It provides characteristics such as friction, smoothness, noise control, and drainage. In addition, it serves as a waterproofing layer to the underlying base, subbase, and subgrade. The surface course can vary in thickness but is usually between 150 mm and 300 mm. So I will repeat, the surface course can vary in the thickness but is usually between 150 mm, 6 inches for light loading, and 300 mm, that is 12 inches for heavy loads and high traffic. Figure shows a 300 mm, that is 12 inches surface course. On the next slide. So here you can see the top view of the PCC surface, and here you can see the surface course, and this is the thickness of the concrete slab. Then comes base course. The base course is immediately beneath the surface course. It provides additional load distribution, contributes to drainage and frost resistance, uniform support to the pavement, a stable platform for construction equipment. Bases also help and prevent subgrade soil movement due to slab pumping. Base courses are usually constructed out of aggregate base. A simple base course of crushed aggregate has been a common option since the early 1900s and is still appropriate in many situations. The other options: stabilized aggregate. Stabilizing agents are used to bind otherwise loose particles to one another, providing strength and cohesion. Cement treated bases, CTBs. Cement treated bases can be built to as much as 20 to 25% of surface course strength. The other option is dense graded HMA. In situations where high base stiffness is desired, base courses can be constructed using a dense graded hot mix asphalt layer. Other option, permeable HMA. In certain situations where high base stiffness and excellent drainage is desired. So here look at that, excellent drainage is also required. In that particular case, the base courses can be constructed using an open graded HMA. Next option is the lean concrete. Contains less Portland cement paste than a typical PCC and is stronger than stabilized aggregates. Lean concrete bases, LCBs, can be built to as much as 25 to 50% of the surface course strength. A lean concrete base functions much like a regular PCC surface course, and therefore it requires construction joints and normally cracks over time. These joints and cracks can potentially caused reflection cracking in the surface course. Subbase course. The subbase course is the portion of the pavement structure between the base course and the subgrade. It functions primarily as structural support, but it can also minimize the intrusion of fines from the subgrade into the pavement structure, improves drainage, minimizes cross-section damage, provides a working platform for construction. The subbase generally consists of relatively lower quality material than the base course, but better than the subgrade soils. Appropriate materials are aggregates and high quality structural fills. Now look at the subgrade. Subgrade provides support to the overlying concrete slab. If it is of good quality, then slab can be laid over it without providing subbase. Otherwise, if it is extremely poor, then a subbase layer should be incorporated. For design purpose, the only thing to know about subgrade is its classification, and the unit pressure coming from slab to subgrade should be calculated for its selection. However, it must be resistant to moisture damages. Pavement comparison. So look at the flexible pavements. Multi-layer construction, we are having the different layers. At the top we are having the surfacing, then beneath that we are having the base course, then we are having the subbase, and then we can see the subgrade. But as far as the pavement structure is concerned, it is consisted of surfacing plus base course plus subbase. So multi-layer construction. Energy consumption due to transportation of materials, increasing cost of asphalt due to high oil prices. And in case of rigid pavements, we are having the single layer usually, that is the concrete slab which is at the top, and as far as the life is concerned, generally lasts longer and may require asphalt topping due to noise or comfort issues. Well, keep this thing in the mind that our first choice is always the flexible pavement. But if the flexible pavement is not suitable at one particular site, then we can opt the model of rigid pavements, because the rigid pavements option is very expensive. Okay, so we have discussed the flexible pavement and the rigid pavements briefly in this lecture. Now look at the course outline of this part of the subject, that is the pavement engineering. So we are going to discuss the types of pavements, wheel load, equivalent single wheel load, repetitive and impact factor, load distribution characteristics, comparison of highways and airports pavements, design considerations, methods of pavement design, and we will discuss the group index method, CBR method, overseas road note 31, and along with that ASHTO guide for design of pavement structures, both flexible and the rigid pavement. And then we also discuss the Westergaard method. Construction and maintenance will be discussed, and the pavement evaluation and rehabilitation techniques will also be discussed. So if you just look at the design of the pavement, so in this course we will discuss design of flexible pavement by group index method, design of flexible pavement by California bearing ratio method, design of rigid pavement by Westergaard method. Design of flexible pavement using overseas road note 31, design of flexible pavement using AASHTO guidelines, and the design of rigid pavement using AASHTO guidelines. So if you just look at the AASHTO guidelines, these two methods, one is which is meant for the flexible pavement and other is for the rigid pavement. These are the most rational approaches for the designing of flexible and the rigid pavements. So we will discuss all these design approaches in this course. And these are some good books for pavement engineering. So we will be using these books at different stages in this course. Thank you.